Greek life often gets a bad rap. Parties, distractions, GPA disasters. But what if we tested that reputation with real data? Today, we're digging into a data set of over 1,400 first year college students to answer a simple question. Are students in Greek life more likely to end up on academic probation? Let's explore that question with a chi-square test of independence. We're asking, is there a statistically significant relationship between whether a student ends up on academic probation and whether they joined a fraternity or sorority? We want to know if academic probation and Greek life participation are independent, or if they're somehow connected. We're running a chi-square test of independence, perfect for when you want to explore the relationship between two categorical variables. We chose the chi-square test of independence because we have two categorical variables. First, academic probation status, a categorical binary for yes or no, and then Greek life membership, also a categorical binary for yes or no. We're checking whether the distribution of one depends on the other, and we have enough data to meet assumptions because we're going to see each cell has at least 5 expected cases. Coming over to the method map, we know we're comparing groups, we have a categorical outcome, and we have two categorical variables. That leads us directly to the chi-square test of independence. You could also look to the question and see we are looking at this being a statistically significant relationship between two categorical variables. Thus, we see chi-square in another portion of the map as well, conditioned on the relationship factor. So this is a textbook case in either direction for chi-square. If you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. First, start with your research question and hypotheses, both null and alternative. Define your variables clearly. What's the outcome? What's the grouping variable? And how are they coded? Describe the data preparation steps, including how you filtered, recoded, and structured your data. Explain the method you're using and how you calculated or entered group proportions. Mention any assumptions you checked, for example, having at least 5 expected cases in each group when testing groups with proportions or categorical variables, relevant here. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns into a simple test into a publishable mini-study. Chi-square tells us whether the two variables are statistically associated. Key outputs are the observed and expected counts, the chi-square statistic, degrees of freedom, and the p-value. The test compares the observed counts in each group, in other words, how many students on academic probation joined Greek life, the expected counts if there were no relationship at all, and it calculates a chi-square statistic and a p-value from that chi-square statistic. If that p-value is under 0.05, we reject the null hypothesis and conclude that academic probation status and Greek life membership are significantly associated, thus linked. Now to run this in SPSS, we're going to go to Analyze, Descriptive Statistics, and Crosstabs. We're going to put Greek life status as your row variable and academic probation as your column. Click Statistics and check chi-square. We'll also add the Kramer's V to look at our power estimate of the association between our two categorical variables. And for each interpretation, click Cells and choose Column Percentages. Click OK. SPSS gives you a contingency table of observed versus expected values, a chi-square statistic, and a p-value to test the independence. In this analysis, we see that there is a statistically significant difference, but interestingly, it points to Greek students being actually less likely to be on probation, 13.7% versus for non-Greeks. So what's the takeaway here? Yes, there is a statistically significant relationship. Greek students appear to have slightly better academic outcomes, at least when it comes to avoiding probation. But when we look at Kramer's V, we see the effect size is small. The rule of thumb is an effect below 0.1 is small, up to 0.3 is moderate, and above 0.5 is large. Given our effect size is below 0.1, while the difference is significant, the effect size is small. So this result is interesting, but not overwhelming. Still, it busts the myth that Greek life equals academic trouble. That's the chi-square test of independence, a great tool when you want to know whether two categorical variables are connected. In our case, we used it to ask, are Greek students more likely to end up on academic probation? In the next video, we'll look at another way to compare proportions. If you're enjoying the series, make sure to subscribe and follow along as we keep building from one method to the next. Stay curious out there.